answering
Well,
stuff.
if you've been reading the Hacker
good.
News comments, I'm not going to get that bad. So.
We ask questions.
Why do these
nicely.
humans exist?
Yeah. I say this without having read any of the Hacker News comments specifically for your stuff, just knowing Hacker News comments.
Yeah. JavaScript should be destroyed.
Yeah. It was funny too, because it was like people were asking the same question over and over, and they're like, it doesn't work on Firefox or Safari, and they haven't said anything. I'm like, I'm copying and pasting the answer. I've copy and pasted 5 times in the same Hacker News thread. Here it does work. It's coming. That's just never read the comments. Cardinal mistake right there.
All right. Yeah. No, I don't have any questions. Just wanted to just say hi. My name is Chris. I don't know. I do stuff, and here I am, and we're gonna fire questions at you. And I imagine K-Ball's introduction is much of the same.
Yeah, Chris has been AWOL for probably 3 or 4 months, Chris. So we're happy to have Chris back. But
yeah,
he
or at least they're faking it. I'm not sure. They're friendly.
Well, we're contractually obligated to be nice to you. Actually,
I'm excited.
How'd you get that into your contract? I can't. All right,
Chris will make statements and ask questions with a subtle, dry humor that is really funny, and I will hit you over the head with dad jokes and other random stuff. But.
Right. I'm just a really nice guy. So there you go. Now we're introduced. Now we're introed.
Yeah.
I like how I just compliment myself over and over again. Should we start the show?
Let's do it.
All right. Welcome back, one and all, to another episode of JS Party. We have an exciting show for you today. Now, admittedly, I say that every episode, but I really, truly mean it this time.
Jared's excited.
Because we are joined by Eric Simons from StackBlitz. StackBlitz recently made waves with a huge announcement, I think around May 21st, in conjunction with Google I/O, about this new technology they've been working on to help us run Node.js in our browsers natively. So we'll talk about what all that means. First of all, Eric, thanks for joining us.
Yeah, thanks for having me. I'm excited to be here with you all.
And we also have longtime contributor, but not recent contributor. Hey, it's Christopher Bone Skull Hiller. Chris, you're back.
I am, I think. Here I am, I think.
From outer space.
Yeah.
Welcome back to the show.
Thank you.
And K-Ball's here. What's up, K-Ball?
Hey. Glad to be here.
So let's start by getting excited, and then we'll talk about technology, and maybe we'll dig in. Maybe we'll get less excited. Maybe we'll get more excited. We'll see what happens throughout the show.
I don't really get excited.
All right, so just be quiet over there, Chris.
Challenge accepted.
I'll get excited.
Okay.
Eric, if you can get Chris excited by the end of the show, you're pretty much can just raise another round of funding probably immediately.
Deal. That sounds good.
All right.
Let's do it.
So the announcement was web containers, which, like I said in the opening, lets us run Node.js natively in the browser. So we'll dig into like how it works and how you're building this, and we'll talk future. But let's just start off with like, what does it mean when you all say natively, Node natively in the browser? Tell us what that means.
Yeah, I mean, it's essentially running, a direct, API parity version of Node in your browser. It's actually taking, we have this, we've written this tool chain that'll take Node.js, the source code itself, build from source, and actually pull it out. And, let me take a step back. When you look at Node.js, right, if you've kind of dug into how Node.js works, when you require the FS module, the first thing that it does, you're actually touching JavaScript code. Like the Node's built-in packages are just JavaScript code, right? But they inevitably have to pass over into native code on your local machine, and it's like with C++ and that sort of thing, right? So essentially, what we've done at a very high level, right, is the JavaScript stuff will just work. Browsers can run JavaScript, right? But how do you run C++ in a browser? Well, you convert it to WebAssembly, right? So at a very high level, what we've done here is the things the parts of Node.js that punch into your native operating system for access, like file system, networking, et cetera. We've written a WebAssembly operating system layer that actually provides those surfaces, right? But it's actually, if you go in and inspect source on it and compare the Node.js runtime code against what, I think right now we support Node 14.6 or something like that. If you compare that against raw source, it's 1-to-1, right? So it's actually Node.js itself.
So when you're doing that, when you're running Node's JavaScript, like Node packages up an implementation of V8 that is, it compiles. Are you running using that packaged V8 code running as WebAssembly, or are you cutting straight through to the browser's version of the JavaScript interpreter?
Yeah. So really good question. So this comes down to like, how is it so fast, right? And what's, if you kind of like, if you rewind back to the origin of Node.js itself, the web is awesome. Like, JavaScript is awesome. We wanted to use it to build stuff, not just on the web. We wanted to use it to build local applications, right? And, browsers, though, have to be really secure. They have to be really fast. And so to add APIs that expand capabilities take time to do right, because the blast radius is really large. Anytime you open a browser tab, you're downloading and executing code. So Ryan Dahl, the fastest path to bring JavaScript to local was to pull V8 out of Chrome, right? And bring it to local. But we had this divergence where now when you run a local tool chain, you are running multiple copies of V8. You're running, every node process has its own copy of V8 running. And usually there's a dozen processes when you're doing dev or something. If you're using VS Code or Atom or whatever, that's Chrome. It's Chromium, right, for Electron. So you're running another copy of V8 in that thing. And then you're previewing your app in Chrome itself or whatever, and that's another copy of V8. So you have like, dozens of independent copies of V8 running, which is a huge inefficiency. And so what the key insight we had is that, you can actually yield much better performance and security by converging all these things that have diverged over the past decade and use the single copy of V8 in Chrome, right? It's a lot faster. It's more secure. That version of V8 is evergreen. If you install Node 10 or whatever, that version of V8 is out of date. There have been security fixes that have been shipped for it, right? So by actually leveraging what's in your browser, you get all the benefits of the fact that Google is investing, hundreds of millions of dollars into making this the most secure runtime on the planet. So at a technical level, that's the long answer to, yeah, absolutely, right? So this is actually a really big deal, because what makes our local tool chains really insecure is that we had to diverge from being able to run this stuff in a browser and just leveraging the existing engine to bring it to local 10 years ago. And now we're bringing it back and, kind of completing the loop there.
So to make sure I understand, what you're saying is that any JavaScript that's being executed is actually being run by the browser's version of V8. And
Correct.
You're then essentially providing any of Node's like library functions that happen to be implemented in C++ as available in WebAssembly?
Yeah, more or less. And I think there's parts of what V8 does, right? Like we have to, there's certain things that we have to port that, we don't have access to the V8 API in a browser as for security reasons, right? But there are things that we can actually pull out and make run independently in a browser to provide that same sort of functionality. So essentially you lean on the existing V8 APIs available in a browser, or any browser engine for that matter. Or for things that you can't do, they're a bit more lower level, you port them over in WebAssembly and actually use that as the target runtime there.
Hmm.
So there's a ton of C++ code in there that in Node.js that talks directly to V8 then. And if you're running this in WebAssembly, you don't have access to those APIs. That's what you're saying?
Well, out of the box, yeah, right. So like, unless you and this is kind of what took a long time for us to get right, is creating interfaces that, like operating system interfaces, where we could compile out the parts where Node.js does touch native into something that could run as in WebAssembly on top of a WebAssembly operating system.
Huh. Do you follow that, Chris? You're
If that
looking
makes
confused.
sense.
No. So, okay. So, in Node C++, there are all these calls to V8, directly to V8. This is why like the Node Chakra project was like a big effort, and they wanted to be able to decouple Node from V8. But that lost steam. It was like a big undertaking, right?
Yeah.
And so did you like have to go in there and patch Node to actually rip out those calls, or did you create like an adapter that would in say in the operating system, or I don't even know where exactly, but Node would get these V8 APIs from something that pretends to be V8. Do you know what I'm saying?
Yeah, totally. Yeah, it's a bit of both, right? So there's still a lot of there's still a lot of things that we're doing R&D on this front, but the short of it, in certain places, it doesn't make sense for those to call out to V8, right? Because if you're trying to create a new date object, just as an absolutely arbitrary example, right? But like,
right,
your browser can do that really well, right? Like, so for in those cases, we'll just short circuit it and actually just leverage the existing stuff that the browser comes with. And there's a lot of things that you can do that with, right? There are more lower level things though, like file system calls and things like that, where if you want to have the problem, like people have tried to do this before, right? Where they take polyfills and they're like, we're going to polyfill kind of the surfaces. And the problem is that the runtime of Node is pretty specific in ways that aren't even like they're incidental, but it's not standardized. It's incidental, and people have built on top of that now. So it's not just a matter of having all the APIs. It's you kind of need the real thing to run, right? Or at least in the exact same way it would on local. So that's been you're hitting the nail on the head. This is exactly the big challenge in doing something like this. Is how do you where do you draw the line? On do we port this to go into WebAssembly, or do we kind of swap it out for something that's going to be leverage the browser's native capabilities?
Sure, right. So those V8 calls, yeah, it's maybe Node is creating a JavaScript object, but it's doing it in C++, and that's what it needs. That's what it needs a V8 for, right? But so you can rip that out, and you can actually just have JavaScript do it, right? Because there you go. We already have a V8 running in a browser. What you can't just like fake or create or rip out is stuff like file system APIs. Things like what about? So I'm curious about what about libuv? What about all the dependencies of Node? So what about like OpenSSL? What about things like that? Is that part of what you had to compile down to WebAssembly as well?
Yeah, so those all actually have different answers. But like something like libuv, right, is again, browsers have a built-in event loop implementation. Kind of if you look across, obviously all of them do, right? Like it's kind of a key part of making JavaScript work. But so being able to kind of leverage the existing event loops that your browsers have, that's one thing where you can drop libuv as something that's got to be compiled, right? For something like I think one of the key things, right, that we did that there was not any prior art on, right, is actually getting a full TCP networking stack tied up to this, where you can start servers like HTTP servers that are programmatically controlled entirely in the browser security sandbox, right? And so for things like that, like that's more on the operating system side. How do we actually create a TCP networking stack that maps to a virtualized TCP networking stack that maps to the service worker API, right? And so for those, we're kind of tying the core Node internals there to, again, operating system interfaces that you would get on a POSIX sort of system, right?
Mm-hmm.
Right. libuv provides Node's event loop, but it also provides system calls. So you could use leverage the browser's event loop. But what about those system calls then? I assume this is where this kind of WebAssembly operating system comes in. So
yeah.
Because you need like a virtual file system to talk to, you need to be able to make system calls somehow. So can you tell us about that? What is this operating system? Like, what can it do? Like, where'd it come
Yeah.
from?
Yeah. So yeah, there's been a lot of like, kind of like getting an OS to run in a browser is not necessarily a new thing. Like, this is kind of one of the main demos that, like ASM.js back in the days, like they got like Linux running and, as a JavaScript file or whatever, right? So that the problem with cross compiling an actual Linux OS is that these things are just dog slow when you put them in a browser. So, and for StackBlitz, right, the key guiding principle for our product experience is that it's got to be fast. And our goal is always, it has to be faster than local. If we're going to try, if we're telling developers, hey, you should do development in a browser, it's got to be a better environment. That means faster. And so this was a really key part of the challenge that we had to figure out. And we took a couple of different stabs at this, but we ultimately, sat down and was like, we've got to bite the bullet. If we want the speed that we're looking for and the very light payload size, this thing clocks in like under a megabyte, we're going to have to do this from scratch and write this thing using Rust. So it compiles out to be pretty optimal size for a WebAssembly module. And we're going to have to identify the things that developer environments rely on and really do a first principles ground up approach here. And it took literally years. But that's essentially what, that's the short of it, but it's 1,000 iterations, that it took to kind of, figure out what are all the POSIX sort of interfaces that Node.js requires, that, and not even that, what are the tools, like when you look at developer repos, what are they relying on? What are the third-party packages doing, right? It's like part of it is just Node.js itself. And then, the ecosystem does a whole bunch of crazy stuff. So testing across all of that has just been an 2 years of trial and error, essentially.
Let's zoom out and back up. I'm sure we can get right back into the weeds here soon. And I appreciate the weeds as much as anybody does. So I'm not trying to, but why would you want to do this? So let's answer that question. Because running Node in the browser, why? Like, what does that unlock? Let's tell us what it unlocks today. Maybe we can dream a little bit. Some of us get great ideas immediately, like, oh, I can do this, and I couldn't do that before. Others sit here and like, well, I don't even know why that's cool. I mean, it sounds like a lot of work. Sounds like you guys have been working hard on it, but why? Why do this?
Yeah. There's a handful of benefits, right? And I think for StackBlitz, what was the key insight that led my co-founder and I to start the company was that, browsers are like really powerful. They're like way more powerful than I think anyone has realized. So like, 4 years ago, the first version of StackBlitz, which, is still online today, it was this custom version of Webpack you could run in a browser. And what was really nice about that is that browsers are a very consistent environment. So if I want to create a bug reproduction, send it to someone, you can instantly have these things online, right? But it allows you to actually merge, kind of like what I was talking about before with like V8 coming out of the browser with Node and then bring it back in. We can actually leverage all the amazing built-in stuff in our browser to have a much better development and debugging experience, right? So like if you're like, one of the key examples in like the blog post, right, is, if you want, like when you run a Next.js toolchain at StackBlitz versus on local, if you, with the advent of server-side rendering, you need to be able to debug what's going on your server side. And debugging with Node.js it's not impossible, but it's like, it's not as easy as popping up Chrome DevTools and just hitting the debugger, right? With StackBlitz, it's now possible to do that. You can actually, as one of the demo videos we got is, right, is like you can have a live API endpoint. When you go to the server, if there's a debugger statement, it'll actually stop the request from responding. You can step through the debugger and do your thing. And that requires no installations on your computer, no extensions, whatever, right? So like it's essentially taking the best of what browsers allow us to do for front-end development and now applying it to this full stack sort of world that we're moving towards with things, I mean, like the Jamstack sort of space and like what Vercel is doing with Next.js, right? And of course, it's ridiculously fast because you're not paying the multi-process overhead that you would on a local computer when you're spinning up all these copies of V8 and whatever have you, right? So it's actually faster than your local machine to do your development builds and even production builds now.
Yeah, that's cool. And some of the other things you go into is potentially and in a world where this thing was prevalent and available and existent, you could have, for example, multiple branches side by side in two different tabs, and like the full code plus development environment in tab 1 on this branch, and the full code plus development environment in branch 2 on that in that tab.
Yep.
And just have those be isolated sandbox things that you can flip back and forth between without any sort of setup or environment isolation on local host. So that's a really cool idea. It seems like a lot of these things are really dev oriented in terms of like, is Node in the browser mostly about improving the development environment, or are there actually production implications of like, once you send your code into the world, are you going to be shipping Node into the browser to your end users as well, or just when you're developing things?
Yeah, I think to start, like we're pretty focused on the development aspects because the benefits are pretty immense for the reasons you outlined, right? Setting up local environments is a pain for experienced dev and a huge barrier to entry for people who are entering the market, right? And so it's, being able to have this stuff open in a tab. I mean, companies spend like weeks having developers get onboarded to like a code base, right? It's like the idea of being able to like crack open a browser tab and be able to like commit code on your first day at a giant Fortune 100 company is like pretty wild, right? But I think that, there's an interesting future here though that you're pointing out is like, well, and this is kind of what the Chrome team's like doing, or the Fugu initiative, right? Like, can web apps replace desktop apps that are currently using Electron? And the answer is increasingly becoming like, yeah, they can. But they do lack right now some of the APIs and developer experience that you would need for some of these things. And so we're kind of interested in seeing like, could this be something that other developers could use to ship, desktop grade applications in a browser, right?
I think you mentioned the Chrome, the experimental file system API, or maybe that was just in some sort of press release or something. But that seems like it would open up, instead of talking to a virtual OS, you could actually talk to the user's file system. Of course, there are a ton of security implications there, and it's probably a minefield, and there's probably a lot of people that don't want browsers to do that sort of thing. But there you go. It seems like that's you could use something like this, and
yeah. Well, and that API, maybe to some people's dismay, is actually shipped stable in Edge and Chrome right now, right? So like, web apps can, they can actually request, and like we have, if you go to StackBlitz.com/local, you can like try this out for yourself. But you in Edge or Chrome, that is, and it's exactly that, right? Where it's wild. You're giving the StackBlitz web app read and write access to a piece of your file system, like you're like a Next.js app you're working on or whatever. And you could not have NPM or Node or Git installed on your computer at all, but it would be running locally on using your CPU, NPM, Node, and Git inside of StackBlitz, inside the browser security sandbox now, right? That's pretty wild. Like you don't have to have anything installed, but you can be having read and write access to your actual file system. And so for us, that's been a key thing that we've been really waiting on for them to ship stable, because oftentimes you will have things installed. You do need to run things that will only run in your local environment, but the file system can act as really the bridge between an online quote unquote IDE versus something you have to run locally now. So I think over the next 5 years, I think we're going to see a lot of desktop apps turning into desktop PWAs because they install instantly. They can do everything you would need to, right? An Electron app would, and et cetera,
So today, could I open up StackBlitz and then like find a working copy on my machine and ask StackBlitz to open it, edit some files, save them, and then go back into my terminal outside of StackBlitz and like commit those changes? Could I do that?
Yeah, you absolutely should be. If you go to StackBlitz.com/local, you can open up from your local machine. That said, it's like, it's buggy largely because we just got, kinks to work out. But, by the end of the summer, or if not sooner, like that's kind of our target, is that there's zero reason why this can't be a a desktop grade IDE where you do exactly what you described, where you mount the folder, you can use it just like you would use VS Code to make the changes. And you could use it even just as an editor. You don't have to run commands in StackBlitz if you don't want, right? But you can use it literally as an editor. And then on your local machine, pull up your terminal and commit the changes that you saved from StackBlitz to the FS, and then commit it to Git or whatever.
Huh. So there's something that's been, and this is back to an earlier part of our conversation, but something that's been chewing away in my head, which is around versioning. So if I understand right now, you're teasing apart the JavaScript interpreter V8, and you're now using the browser's version of that, and you're implementing some version of all of the other different Node APIs. Do you ever run into version inconsistencies, like places where I'm not super familiar with Node internals, but I would assume that if they're interacting with V8, they're making assumptions about this version of V8, and they're testing with a particular version of V8. And if you unlock that, suddenly you're in the browser, and you could be with whatever version of V8. Evergreen version of V8, right? Well, Evergreen is great, but like when they do browser stuff, they're testing with a single self-consistent version. It's not like they're separately evolving pieces. They're shipping every 6 weeks, right? And they have a test cycle.
Is
so
Node
here
pinned to specific versions? Is that something that we know? I mean, you probably know, but I don't know. Does it get pinned like at a release date? Like this version of Node speaks to this version of V8.
Yeah, because Node bundles its own, just like Electron bundles its own copy of Chrome and therefore
Right.
V8. Node.js bundles its own copy of V8, right? So it's kind of a static, snapshot. But the thing is, and so like it's a great question, right? Because that is it's less of a problem than you might imagine, but there are interesting ramifications that will, as we go forward here, we'll have to solve for, right? Because it's less of that there'll be backwards, because the whole idea of browsers is that Google still has test cases from like 1995 or whatever, right? Okay, they're probably not that far, but like 2005 or something, right? Like they test all these different things and make sure that they still work, right? And that's a key design requirement for browser vendors, is that they don't break backwards compatibility, right? So but they do introduce new functionality, right? They do introduce top level await. They do introduce that. And so what you could end up happening, right, is if you're using a newer copy of V8 than Node 10 does, the user could write code in a web container that would run, but if you brought it to local, it wouldn't, because they're using a very outdated version of V8, right? Because unfortunately, it is a design flaw in our view. It's a design flaw that we're bundling a copy of V8 that goes out of date the day after, right? There's a nightly that's newer the day after that these things get released, right? It should be evergreen. Why do we want to do snapshotting? Browsers, the same thing. Like why can't we take what is great about web browsers, which is that they are constantly adding capabilities, but have a really good job of supporting backwards compatible code, that was written 20 years ago or whatever. Right. So I think this is kind of like, this is the merger of those two worlds in our view. That said, I think it's, a year or two from now, we'll have, as code is getting executed, it's like, I think that the big question is, hey, async await doesn't work in Node 12, right? So, or whatever, so like we have to like make sure that code throws an error for the user or something like that. But those are kind of the main things that you have to be conscious of.
Yeah, they also ship progressions occasionally and things like that, right? Like I know don't break the web is a wonderful concept, but one of the nice things about server side is like if you lock down your environment, you can absolutely test things and know it's going to work. And you mentioned that like the browser is less variable of an environment. I think that's true rather than shipping desktop software, but it's blatantly false when it comes to shipping like application software, right? We can completely control and lock down our application server environment.
Right.
And we cannot do that in the browser. So
yeah, no, it's a really good point. Sorry, I didn't mean to cut you off.
No, go ahead. I'm trying to wrap my head around this because I'm thinking about like, this is an interesting model for deploying software, but it feels like it actually walks in between those lines of things that we used to have locked down or able to be locked down, even if not everyone was locking it down, and stuff that's going to be like breaking in this environment versus that one? What version of Chrome are you on? Are you using Firefox and you have a completely different JavaScript interpreter? Like, how are we doing
Yeah.
this?
Well, it's Chrome
Yeah,
only,
totally.
right?
Well,
That solves that problem.
it runs today in Firefox. There's a couple of bugs with small. I mean, we don't have it available publicly just because there's bugs that we got to work through on the thing. But we built this on web standard API. So and Safari is doing their best to ship
One of these
WebAssembly through. Yeah. So yeah, I mean, like enough said, I guess, on that end, right? But like, you know, this stuff is standardized, so it looks like they might ship it in the next 6 months, maybe, you know, like WebAssembly threads and that sort of thing. But the point stands of like, you can take, because like StackBlitz has like, we're a business, and the way we make money is we actually sell an enterprise version of StackBlitz. You can run it behind a firewall, right? Which when you talk to Fortune 100 companies that are doing literally trillions of dollars in transaction volume, they will not use AWS, right? They can't afford to. They have to have their own data centers, right? Where they're running this stuff. And the benefit that they see from this approach, it's a double-edged sword. Yes, you can lock down your environment, which is how we deploy our cloud native software behind their firewall. But the reason they want StackBlitz, being able to utilize the browser is because it solves a ridiculous number of security issues. You can create a container that's going to work the same everywhere. But if you're using, if part of that container is code that it can be infected, you're opening your company up to supply chain attacks that are on the rise, right? And so that's the double-edged sword here is, do we want to live in a world, right? Well, and it's an individual basis, right? Like, for Fortune 100 companies, the answer, they'll take security every day of the week, right?
Yeah, virtualization with WebAssembly gives you some very clear security wins, but I do wonder about, like, you could potentially get that by shipping a WebAssembly runtime that is not running in the browser and doesn't have these same sort of mismatch version issues, right? You just lock it down, ship Node some version of WebAssembly runtime.
But you're relying on the implementer. You're relying on whatever is bridging out to your local machine for that WebAssembly interface. You're relying on that implementer to not have any vulnerabilities in their code base.
Same as the browser, right? We're relying on the browser.
Right. But bingo. But Fortune 100 companies, everyone has approved Google Chrome as a browser. These Fortune 100 companies already they have allowed a runtime explicitly for everyone at the company to use that they trust security wise, because if for a good reason. Google's got 15,000 cores right now while we're sitting fuzzing that code base 24 hours a day, 7 days a week, and they've got the 0-day team. This company is leading the web security industry. They take this stuff seriously. And so if you're gonna say, hey, we're gonna introduce a WebAssembly runtime that's more local based, right? Which I have no doubt one will pop up, right? But if I were gonna bet money, I think it's gonna probably be based on all of the work that Google does from a security standpoint, for the exact reason that Cloudflare uses V8 for Cloudflare workers.
I might actually see us pulling out, the WebAssembly runtime from Chrome. And it's a different set of trade-offs, but yeah, it is an interesting thing. No,
I'm not disillusioned thinking that this is, the world's software is all going to run on this stuff overnight. But I think the benefits are pretty enormous. I mean, certainly from a security angle, but also from a speed angle, because V8 isolates are incredibly fast for compared to local operating system processes. They're much more secure and very fast for context switching. And so, like with Web Container, your Node.js applications run 20% faster than they would on local. So even as a developer, we're kind of marrying like security and productivity. Normally you only get to pick one of these things, but when you use StackBlitz, right, you are more productive. Your builds finish faster. You can code faster and build faster, and it's far more secure, right?
That's the interesting part for me, because I've seen a lot of these things come and go. Put your development environment in the browser. I remember back when Heroku was actually that. Before Heroku was successful, their first version was, hey, it's an IDE in the browser. Isn't this cool? So it was a complete Ruby on Rails environment in your browser. And it was really impressive, and nobody wanted to use it because it was the uncanny valley, and it was slower than localhost, and you ran into issues, and you couldn't pop your terminal and just do a terminal command and then hop back into it just never has worked. And so if you are able to pull this off because of the speed, if it delivers on the speed promises, which we see in the demos and the GIFs, if that works out in practice, I think you'll have a compelling environment, whereas nothing has convinced me ever that I should put my development environment in my browser to date.
Absolutely. Yeah. It's kind of like we've seen over the years, like web ID after web ID, and they all are just like not as good as a local environment. And
Right.
so I think, this seems like a solving one of those problems for sure. That's stopping people from using it.
I think you hit the nail on the head too, because that's kind of been our viewpoint from day one, is that this, for people, why would you move to an online IDE if it's not going to be better than your local environment, right? It can't be as good even, right? It has to be better. Otherwise, what's the incentive? And then when you break that down, it's, well, what do we care about as developers? How fast can I get my ideas into my fingertips through the keyboard and get a response back from the computer? It's speed. Right? How fast can I get a response from the computer? And also, with the supply chain attacks increasing for people who are employed at large organizations that have a lot to lose, how can this give me a secure by default guarantee, right? And runs consistently, I think, because that, the works on my machine issue, right? Like that's, I think those are the key things to us, at least, that really matter for this to work. And by the way, you can try this out. You don't have to be logged in, because the beautiful thing is that you can go to StackBlitz.com, click the Next.js starter project. You don't have to log in, because it doesn't cost us anything to run. Like, I think our servers cost, less than $1,000 a month. And we've got, 2-3 million developers that are using the product, right? Because it's all leveraging your local CPU and memory. So you can try it out for yourself to see just kind of how fast it is. Yeah, anyways, I could go on, but
well, we'll break right here, and then we'll talk about how fast it is and why it's so fast after this break. All right, so now we are in a break, so we can relax and hit the bathroom if you have to, or take a drink. I have my live stream brought to you by Pure Leaf. No, it's not, but
I'll be right back.
But if Pure Leaf, if you're out there and you want to sponsor us, I would love some free tea.
I took a workshop last weekend, and they were like, yeah, so does everybody have their purple coffee? By which they meant red wine. It was 8 a.m. It's like
purple coffee.
No, it wasn't 8 a.m. where they were, because time zones, but still.
Oh, okay. I was like, dang, they're hardcore.
These are great questions, by the way. Yeah, these are some very technically advanced questions. I love it.
Warned you would poke.
only Chris is the only one that actually has a neck beard, but we've all been around long enough to know what questions to ask.
Totally.
And he trimmed up his neck beard for today's show, so we appreciate that. Okay, so well, we can game plan this. So we touched on it, but let's more directly, K-Ball, you can lead this part. We'll directly address why it's faster. I know you've said that already, Eric, as kind of like a passing thing, maybe just like put the nail on the head there. And then we want to talk about ecosystem stuff, how NPM and packages all work into it. I also want to like talk about web containers as their own, like that's the technology. And like, where does web containers stop and StackBlitz start, and what's open and what's closed, and that aspect as well. And then we'll probably be out of time by then. So that's my plan.
Sounds good.
What do you think, K-Ball?
Yeah.
Put that in your WebAssembly runtime and smoke it.
Yeah. Well, it's really interesting, the model of separating the interpreter, because I was initially thinking you were actually compiling. You were like virtualizing V8, so you were running V8 on WebAssembly.
Which doesn't make sense, right?
Which doesn't. Well, yeah. It doesn't with the performance that we're seeing.
I'm saying it's the easy button, but it doesn't make sense technically. He wouldn't. It's like it's stupid in terms of like thinking about it, right? It's a bad idea performance wise.
Probably
it has to be dog slow.
Today, at least, yeah. Maybe with some of the garbage collection specs that WebAssembly is kind of pushing forward, it could actually be. It wouldn't be as fast as just V8 itself, but I think it's also the decoupling makes a lot of sense. I think from a security standpoint,
Yeah, it's really interesting though.
All right, let's not put too much good stuff in the breaks. Let's go back into the show.
I'm ready.
Everybody ready? Okay, drop a marker.
Cool. I'd love to dig in a little bit more on why it's faster. You've sort of mentioned a couple times that it is faster, and you have demos that show that. And I was thinking about this, and I was like, okay, there's a few different angles, and I'd be curious to think of. So one possibility that I was thinking about is like you've essentially moved all the stuff that lived in the kernel into user space, and you probably simplified the set of things it has to handle. So by virtue of not dipping down into kernel space, you don't have any sort of like process changing or anything, and so that piece could be faster. And then the other piece I was thinking about is you're mostly simulating web stuff. So you could probably shortcut the network connection. So like what would be a local host connection that's going through, your local network device and HTTP and all those other things, you could probably put shortcuts in. And then there might be other things that I haven't even thought of. So I'm curious, what is it that's making it so fast?
I'm guessing that's the big win, is the networking stuff. Go ahead, tell us.
Yeah, no, it's a really good question. I mean, this is like, we spend a lot of time working on speed because like I said, it's like, this is kind of like what, from a product perspective, this is the number one thing. Like what is StackBlitz? It's fast, right? Like whatever web computers, they are fast. And that's because that's, again, how can we be better than your local environment? If it's faster is better, right? So there's a kind of an array of things that kind of play into this and work in concert with one another for this kind of seamless experience. But like, I think to start off, it's something I mentioned before was V8 isolates. So the idea of not having to spin up multiple literal operating system processes, right, for every Node.js thread you want to run or whatever, right? On local, that actually there is an overhead to doing that. But in your browser, right, when you open up a browser tab, you need the ability to have, multiple web workers and, different like processes, right? But it has to be really fast. Browsers have to be really fast. And so V8 isolates, and then the other browsers, they have kind of different terminologies for this, but essentially it's the equivalent of a single, kind of unique process, more or less, that's running in your browser. And by being able to have one copy of V8 doing that for all of your Node.js processes, the editor that you're editing in, and the web apps that, like when you open up the URL to view your dev server, there's an incredible amount of overhead that's cut there, right? Because you're on your computer, that's actually one operating system process. Every Chrome tab gets its own process, right? And we've virtualized essentially the would normally be dozens of different processes into that same process shared via V8 isolates, which are super fast, super secure for context switching, right? So high level, there's that. I can go on to the next point, but if we want to talk more about that stuff, we can dig in a little bit. But under the hood, that's kind of the bedrock, right, of what makes this fast. Second thing, right, is exactly what you said. So when at least for your dev server, right, you might have noticed like if on local, when you run a Webpack dev server build of any meaningful app, the dev builds are like megabytes in size. And so if you've ever used like GitHub code spaces or Code Sandbox or anything like this, right, they're running it on a remote VM. And what that means is that when they crack open the server for you to, Webpack dev server, when the port opens, you can connect to it or whatever, they're proxying you to that server, and you're pulling down megabytes of, non-minified dev builds, right? So just, it's super slow. It takes forever, right? Because this doesn't leave the Chrome Security Sandbox, i.e. using one copy of V8, right? Those responses from the server go through the service worker API and hit faster than you can even hit a local host URL. And so when you're talking about web development, that's a pretty big win, right? How fast can I see a hot reload happen? How fast can I refresh to see the latest change? With web containers, you're talking about, less than, 15 milliseconds or something, right? To actually see it start rendering. Let's see. I think those are some of the key things there. And then I think on I think what you mentioned around the operating system and kind of like having be coupled, did a ton of stuff there. So I think you actually did a great job explaining those optimizations. But the other side of it is the NPM side, right? So NPM normally takes forever to complete an install. And so this is something when we built StackBlitz V1, we built the like the first NPM client that would work in a browser and was like 5 times faster than Yarn and NPM. And in the first version, the key trick was being able to have a file system that could be lazy loadable from network, because essentially you don't have to download like a gigabyte of node modules. You can actually be really smart about what are the files that are going to get used from node modules. Only download that. And browsers just have gotten really good at just downloading, they're doing, hundreds or thousands of requests for actually really large payloads at this point. And they have great built-in caching mechanisms. So on every page load, actually, we run a fresh NPM install every single time, right? So if something goes wrong with your environment, again, if you look at the other players in the market, like code spaces or whatever, if something goes wrong and you hit the refresh button, it's reconnecting you to that broken container again, right? Unlike every other web app where if something goes wrong with Google Docs, you hit refresh, usually it like works again, right? With StackBlitz, now the same thing is true, because if something goes wrong with your environment, you just hit refresh, it rebuilds the container from the ground up because it takes only a couple of seconds. So you're guaranteed a fresh environment every single time, right? And so it kind of relies on this custom NPM technology we've made. And again, browsers are, they have first-class networking built into them, right? So we're able to leverage that in a way that, would be difficult to do on local.
That's fascinating. So you're redoing an NPM install, but it's essentially hitting the browser cache, so that they're coming from a locally cached version of those packages.
Exactly.
I'm going to get into the weeds a little bit. So how do you handle packages from NPM that have like a post install step, maybe a build or something that they run immediately after you NPM install them?
Yeah, it's an anti-pattern. So 5 years ago, Sam Saccone filed a vulnerability that NPM has yet to address, where essentially the execution of post-install scripts by default on every install you do can enable a very, very, very bad type of worm to propagate. Whereas it kind of goes essentially like this. Open source developer, gets a bug report, and someone says, hey, here's the repo you can download and install to reproduce the bug. Except that person who's filed the bug report put a worm in the post-install script that what it does is scans the current logged in NPM user on that computer, looks at all the open source packages that they have published, and then republishes minor versions to include that post-install script with the code that infected them in the first place. Then that gets published, other people download from this open source, authors' popular libraries, rinse and repeat, and this worm has gone across the entire NPM ecosystem, stealing credentials, wreaking havoc, right? This has been unaddressed by NPM. I don't know why, but nonetheless, it's a huge issue. And again, when you talk about Fortune 100 companies, what happened with SolarWinds? What happened with what is going on with this stuff? Developers are the weakest link in security now, because we're running NPM install and there's thousands of things that we're installing that we're not even necessarily aware of, right? And so these people have security teams, but these things can slip in. So by removing post install as a default thing that happens, you actually eliminate this attack surface, right? And you can introduce ways where you say, hey, run this specific command where the user has to take intent to do an action, right? A lot of the time too, these post install scripts are, downloading, compiling, and running binaries, which, is not great from a security perspective necessarily, right? With kind of the transition that we're seeing, right? I think the industry's seeing, there's a lot of things that should be WebAssembly modules. Like if you look at what Next.js is doing, they swapped their Sharp image optimization to a WebAssembly variant because it's faster, it's more secure, right? Huh. There's a lot of binaries that shouldn't be binaries. They should be WebAssembly binaries because they run everywhere. They require no post-install script. They're directly inspectable. There's a lot of benefit. Like I think 5-10 years ago when the NPM ecosystem came up, sure, yeah, this WebAssembly didn't exist. Different world today, and lots of attacks happening. So different world, and in a world that actually needs a more secure binary runtime format like WebAssembly, right? So anyways, off my soapbox. But.
No. But so I'm not going to argue whether or not they are an anti-pattern, but my understanding is they are still supported by NPM. So how does that work in a StackBlitz world? We
don't run them. We don't, and if we find packages that have a post install script, we say, hey, we don't run this. For your security, you can learn more about it here, or if you want to run the script yourself, you can do that. This is an important thing for the ecosystem as a whole to take seriously, right? Like and it might sound like we're being like ridiculous about this, but if/when this happens, right, which Sam Saccone has gone on the record going, it is a matter of time until someone does this, right? It's a matter of time. We need to take stuff like this seriously. I think that node ecosystem. You know, I think it's getting to a point where security has got to be a first class consideration with how we're building our software, right? And actually just across the entire software industry. We are the weakest link. We got to take it seriously.
I mean, regarding the worms, since it's been brought up a couple times, you know, NPM didn't introduce two-factor authentication, which, as you're describing it, would be exceedingly difficult for a worm to propagate if it had to put in the one-time password to publish something. But I mean, it seems fair to me if the companies and you know, if the intended audience for this this tool prioritizes security to, you know, kind of essentially disallow scripts on install. If that's what they don't want them to happen, then great. And yeah, I agree. A lot of things should be WebAssembly modules, right? But say that you do want to use something that, I don't know, it needs to grab a binary. God forbid it needs to compile something. What happens? Like, can your OS compile things? Like, what can it do? And, you know, in terms of, like, is Bash running? Like, how does that work?
Yeah, we've got a you know, kind of a slimmed down you know, shell, right? So I think pretty soon you'll be able to actually, like, you know, execute kind of Bash scripts in the thing. But you know, I think that there's some stuff going on where you could actually compile you know, tool chains and binaries, whatever, in the browser itself, for sure. I mean, I think the work that the WASI folks are doing, right, is kind of paving the way for this future to happen. I think that we're kind of betting on a larger trend, right? Which is, you know, the world is going to move their software more towards web-based computing, like WebAssembly. And if that's the case, then yes, you're going to end up with WebAssembly modules that compile Python into other WebAssembly modules or whatever, right? And this stuff's already starting to happen, and that strikes us as the right way to do this. You know, using a secure by default, you know, runtime to produce more secure by default, you know, binaries for runtimes or whatever, right? But yeah, I mean, and to answer the direct question, like, what happens if you need to, like, compile I don't know, like a JVM or something, you know, if you try and download, yeah, it's not going to work, right? Unless it's, you know, using a WebAssembly module to do the actual compilation work, of course. But yeah, I think it's a feature that it can't, in a sense.
Mm-hmm. So let's tease apart, or we're running a little bit low on time here. Before we go, I definitely want to tease apart web containers versus StackBlitz. The announcement, the new tech is web containers. There's a GitHub repository. There's a working group. There's things that look very open and collaborative. StackBlitz, like you said, you're a business. You can run Node.js in your browser on stackblitz.com, but, like, can you run it in your browser other places? So what's the collaboration and the open story here? Is there one? And how do we differentiate between what's StackBlitz proprietary tech and what's out there to be used by everybody, kind of stuff?
Yeah, totally. Yeah, I think right now, so we're, you know, this stuff is very new, and we're still figuring out a lot of it ourselves. And so that's why we're in an open beta for people to try it out and kind of push the limits of it, because there's still a bit more that we need to learn about how to make something like this very runtime compatible and cross-platform compatible, et cetera. At the same time, kind of leading from what we were just talking about, we also need to get developers to think about how they're running their tool chains a little bit differently, right? I mean, and again, our pitch is it is faster and more secure to do it using WebAssembly based tool chains, right? Or you know, leveraging the, you know, billions of dollars getting poured into browser innovation, right? But in order to do that, we need to we need to make sure that it's seamless, because it's a key design goal. If you go to like our web container working group repo, one of our key design goals is that this should not be something that requires you to change how your code base is set up to work. It should just, quote unquote, just work, right? So that means there's certain packages that are not available as WebAssembly modules. So we got to flip those over, right, as a community. Kind of a host of other things. But as far as like, what is the today, where the community is really helping is helping those larger shifts happen, right? Which and there's just a ton of people who are doing this now, which is so awesome to see, and also giving us feedback on the core runtime and helping us battle test it. Because what we're tracking towards is like a general availability release, sometime end of the summer or fall or something like that, and we want to expose it, like enable developers to use this thing, with like a really like great API surface. And perhaps introduce standards, like actually introduce standards where there are currently gaps in what, browser vendors are doing, or WASI or whatever, right? So we're trying to get a bit of a lay of the land to understand exactly, how we need to go about solving these problems in a way where everyone can leverage, the power that's in their browser to ship better, faster, more secure applications, right? So that's kind of the long-winded version of it.
Something go ahead.
Sorry,
Chris.
I guess what I don't understand is like, is there a portion of this that is open source, or is it all proprietary, or how does that work?
Yeah, so today everything is largely closed source. Our intention is that this is going to be a ever receding closed core, right? Kind of like if you look at what like React Native did. They did not have it publicly available for a very long time as they were hammering out a lot of the core issues. That's kind of how we view this, and I think the npm client thing is a great example of that. Like we've got the fastest, most secure npm client running in this thing, and there's no reason we shouldn't release that as open source for people to use in their local environments as well, right? I think like over the course of the next year, a lot of the things that you're seeing in this, as we stabilize them, it's not even just going to be applicable inside of StackBlitz. It's going to start hitting people in their local environments as well, right? And so that's our intention. But in order to do that, again, like we have to make sure that it's a very seamless experience for the person who's going to adopt this thing, and make sure that it's not going to cause them, a huge migration effort, or it's going to break or whatever have you. So that's like very valuable. What we're doing right now is getting a lot of test data in lightweight environments, because people aren't trying to use this for work that is tied to their actual job or something right now, right? So we want to make sure that we're pretty confident before we start rolling this out for people to rely on for their jobs, for the livelihood.
Something you said about getting this available to everyone made me wonder, is there a plan for supporting other backend languages? And I think there's an interesting question there around the performance benefits, because like the sharing the V8, what were they called, instantiations or whatever it is, like that benefit's not going to be there. You are going to be virtualizing some sort of runtime or something into WebAssembly. But some of the performance benefits you've talked about could very well generalize, right? Like the idea of package installation and utilizing the browser cache, the idea of cutting out the network stack and being able to directly access things. Like, does it make sense to have web containers for running Python on WebAssembly, Golang on WebAssembly, Rust already kind of goes straight to WebAssembly, but like, does it make sense to expand this beyond Node?
That's our goal, right? For sure, right? Like we think that that's absolutely how it should work. That you should, like, today JavaScript is the easiest language, certainly the most sensible one, because if anyone's going to understand the value of an online IDE, it should be web developers, right? Like, we should be able to build the web using the web. But if you kind of look beyond that, the same benefits can absolutely apply to other languages. And so I think that's the longer term view here. And what's going to be the hardest part, and why we've put together a working group to start thinking about these problems, because you've also got the WebAssembly standard interface, the WASI folks who are trying to help bridge this gap, right? Because WebAssembly is great, but it does not specify how you access a file system or TCP networking or whatever, right? really important APIs for most binaries to be converted to a WebAssembly module. And they're doing a phenomenal job on that. And so StackBlitz is going to have like a WASI standardized interface available to developers, in the next month or two here. So you'll be able to actually, run Python or et cetera. And to start, it's going to be, you'll be running the Python REPL or something like that, right? Because there's going to be, again, as an industry, we're going to have to make some structural changes to enable the ease of adoption and performance and et cetera that you'd want in order for this to be a viable switch from your local environment. But we want to apply momentum in that direction, because that totally, right? Like that just seems like the future. Seems like a better future, at least.
Super cool stuff, Eric. See, we're all excited now. Even Chris is excited. We're all excited. You've done a good job fielding our questions. I'm sure
a couple of head nods, just the small ones, but it's cool stuff. No.
Yeah. So,
hey, I saw a smile from Chris. That's like, well done, sir.
Well done. You passed the first
These are really
test.
good questions, by the way. These are like very, very on the nuts and bolts of exactly, what's going on here. So I really appreciate having me on. This has been a lot of fun.
You bet. The listeners, all the links to all the things, including that introductory blog post and places where you can go to watch the demos for yourself. And do you watch a demo? No, you try a demo. Go try the demo. See how you can get it running in your browser, Chrome, and maybe Firefox here soon. It'll be exciting, Eric, to watch you guys make progress. Like you said, this is early days. This is announcement. This is excitement gathering, but there's a lot of work left to do. So we'd love to catch up with you maybe in 6 months to a year and see how far y'all have made it and what is out there to be used and advanced from there. So thanks for joining us. We really appreciate it. Chris and K-Ball, awesome as always to have you here with us. And that's our show. We'll talk to y'all next week. All right. There you go.
Awesome.
You're now in the post show. It's like a post install, but it's but we execute.
But more secure.
More secure. Maybe not. You never know what's going to happen post show.
Hey, we made it through an entire show without like improvised singing or.
Yeah, we didn't do anything. It was a very serious episode. There was no silliness. So.
Yeah, it was not quite what I was expecting, but it was a lot of fun, nonetheless.
Happy to hear it.
Really,
What were
genuinely
you
great questions.
expecting?
I don't know. I don't know. I've been on a couple of podcasts before, and usually it's more product focused than just kind of like under the hood technology. But this is cool. I mean, this stuff we've been just banging our heads against the wall for the past 2 years on. So it's like it's fun to have a conversation with people who can appreciate and can kind of poke and prod on the stuff that most people wouldn't know kind of is going on under the hood there.
You sound like you were probably down in the trenches a bit on this.
Yeah, that's a word for it. Yeah. This was a tough one. I mean, it's one of those things where you can work for a year or two on it, and then at the very end zone, you're like, oh crap, there's this giant thing that we would have never known. Yeah, exactly. Right. Yeah. So the entire way it was just a nail biter. So it's good to have it out there. We got our work cut out for us for sure. So, but
how big is your team?
We're about to hit 12 people. And we just added, we've doubled, I guess, in the past 6 or 9 months here. So yeah, we got a pretty small team.
Cool. I got to run, but this was fun. Thanks, Eric.
Cool. Yeah, Eric, I'm going to throw a uploader link into the Zoom chat there. Chris, WAV file's fine from Audacity.
Perfect.
And,
yeah, I'll upload
just
my...
name it JS Party Eric. Upload it there. And the show goes out. We're on a 1-week production, so this will go out. We ship on Fridays, so a week from tomorrow. And you're in our system, so you'll get emailed by our robots and all that jazz, so you won't miss it.
Awesome. All right. Sounds good, guys. Thanks so much for having me on. It was a blast.
Thank you.